Here you can experience the architectural design possibilities of EliteCAD. The first step is to put in the building specifications, define the number of floors to be constructed, and type in the floor to ceiling heights. A section will let us quickly test these dimensions, but here we have direct influence on the building structure through defining the floor heights and corresponding floor construction. To create a precise design, it is often necessary to include the surrounding terrain. Should you not have any landscape measurement data, you can simply put some points into EliteCAD, and the program uses these points to generate three-dimensional terrain. The terrain created by EliteCAD is made up of many points positioned in space and connected together to form a three-dimensional mesh, which is both flexible and modifiable. At any moment, it is possible to pull at one of the contour lines and thus manipulate the whole terrain. Now we can put in a cadastre copy, which can of course comprise of multiple points, to cut the property terrain to the right size. Even after being trimmed, the terrain remains adjustable. When a point is moved or a contour line is dragged, the adjustment has effect on the whole three-dimensional terrain. Now we will define a couple border margins. In this case, we put a dimension of 5 meters. We can place some guides onto the margin lines so that we can later refer to these lines during the design. Now we define the building perimeter to see what such a building could look like. We build this perimeter up as a unit, can drag it, and subsequently make adjustments to each of the dimensions. We simply click on a line and specify that we want this line to be 300 long, and then specify in which direction the whole perimeter should be extended. We define the geometry of diverse lines by clicking on them and putting in new dimensions to precisely match the building perimeter to objects of comparison. After having defined the building perimeter, we click on it and link it to the already established floor height specifications. We have now created a comparison object. This object can be adjusted from any desired view. For example, we create a selection of different elements to which adjustments can then be made. This is an interactive modeling process, which at all times shows clear and precise geometry. We have the possibility to make changes to every edge and corner. Here, for example, we can pull out the balconies. Then we go to the building, highlight the roof and the ground floor in order to make further changes to the building's geometry. So it is possible to make changes to the model from any view, not just from plan or a section, but from any angle, and of course in a perspective view as well. Using simple click and drag method, we are quickly able to extend floors, push and pull walls into the right position in an interactive yet precise manner. As you can see, we can use existing points of the model as reference points. Now we can make the building structure ever more precise. We can develop it by adding details such as columns. To place these columns precisely, we have a function that, for example, divides the wall into 3 and allows the columns to be placed exactly on these new points, thus being evenly spaced. You can see we can use this interactive design process to place the columns, which will then be visible in the model, the plans and the sections. We can also create openings directly into the model, for example, a window that extends over multiple floors. We turn the view so that we can add another window directly into the facade. The windows can, for example, be created by stretching a polygon over the desired location. Although there are precise underlying measurements involved, the program allows for a simple interactive manipulation. We can add windows to other facades while using existing windows as reference points for the dimensions and heights, thus saving us a lot of time not having to type in the measurements for each new window. Now we can extend the floor plan with the walls. We select a brick wall from here to place it directly into the plan. Here we have the possibility to add desired wall sections into the building. The walls naturally fit well with the outer walls so that we have clean edges and intersections. We also have the possibility to extend walls in this way. If you have the feeling that you are only working in plan, you can switch back to a spatial view where all the values are displayed in 3 dimensions. Now we can add some doors into the plan. These can be placed and moved, and with another click are fixed into position. You can see that building components can quickly be manipulated, flipped and moved through simple selection and copy and paste commands. Although these building components are available as parametric entities, you have the possibility to manually stretch and change their dimensions. We now place a couple of guides into the drawing with an offset of 1.20 m. We want to create a staircase and lift elements and therefore need the guides. Now we select the wall type, click on and drag the line from point to point using the guides. And here we have the lift shaft. Here you have a possibility to add a calculated staircase into the model. We will create a staircase of multiple angles around the lift shaft. We can change the view to 3D and also from wireframe to realistic. It is even possible to make adjustments to the staircase within this perspective view. The staircase model comes in a standard parametric size, the values of which can be changed at any time. We can raise the height of the risers, make adjustments to the stair proportions, and various other adjustment possibilities that you could imagine in stair construction. Now we can add some more walls into the model, using existing walls as dimension guides. Many of the components drawn on the ground floor are also required on other floors. Instead of drawing the components of each floor from zero, we simply select the components we want to use, select the floor we want to modify, and copy the selected components to that floor. Now we can recognize that some of these parts need adjusting. For instance, these walls here are too long and are sticking out. This can be selected and corrected to the right size. The whole dynamic model can be altered at any time. Here, for example, we will add a parapet. We go into the plan and, for instance, follow the ceiling contours to position the parapet here. In plan, the parapet appears like a wall. You see here, shown as 2 parallel lines. Now we would like to create the roof of the building. To create the roof, we set out some guides to position the roof layout, including the roof overhang and contour ridges. We are then able to plot the roof outline by clicking on the guide intersections. We now go around and create the roof parameter and then select the appropriate roof. The roof that you choose depends on your preference. You can create your own roof of multiple angles or choose one of the available parametric roofs. It is possible to adjust and customize any design form and angle. Thanks to the parametric system, the roof remains flexible. You have the possibility to keep going back and make new modifications, thus allowing the architecture to develop. A double click on the roof is enough. We would like to, for example, see what it would look like with a shallower angle, let's say 22 degrees. Here we can quickly alter the angle, change it back again, and set it at different angles, all without having to redraw the whole thing again.